Hey everyone, thanks for joining us today. My name is Matt Stratman. I'm our Director of Global Business Development at Flir, and on with me today is Sean Jepson, our Global Solutions Architect and Program Manager.
Hello, everybody.
Today we're here to talk to everyone about how Flir is handling multi-layered perimeters. This is a topic that I feel is coming up a lot these days, and there's a lot of different approaches out there. But how at Flir, I believe, we handle this in a unique way with leveraging the multi-layered system, and then with our proprietary protocol Nexus to help streamline the installation and better the tracking capabilities. So first, we're going to talk about, when we're looking at a perimeter, what are some of the known challenges that everyone's facing? Some of the most common ones we see are poor lighting, large open areas, inclement weather, connectivity for where we can put devices. It's not always that we have direct line of sight off the building or that we can get network drops in certain areas. So that so often limits our ability to cover some of these large spaces. Every facility is a little bit different, so physical obstructions can't really see through things. So how do we tackle being able to I pick up targets and then track them through with these obstructions in the way? Tracking in general, it can be difficult. There's a lot of different products out there, how they integrate, how we're able to track. We're going to talk a lot today about how Flir helps solve that solution. And then false alarms. These are all things that make defending a perimeter and just getting alarm notification very challenging. Um, so when we kind of go a little bit deeper in looking at the perimeter, um, the old kind of talk track around multi-layers was your first layer of defense is beyond the perimeter, your second layer is at the fence line, your third layer is in the interior, and then going all the way into inside the building and then even to different rooms. When we look at kind of condensing that talk track into four different layers, today we're going to be focusing on the red and yellow layers, so the perimeter and then what we call inside the estate. In those areas, it's the types of technology we're looking to leverage to create a better solution. So, in the red area, the perimeter line and beyond the perimeter line, we want to look at technologies that are going to be able to detect objects that are moving and then also track those objects. As we get a little bit closer, like at the fence line and inside the fence line, we need to really be able to identify kind of what is there and also be able to maintain our tracking capabilities. So when we think about that, we are often, let's say, okay, well, what technology makes the most sense? Ideally, it would be great if we could just use one device to do all of that. But the reality is we can. Every type of technology has their advantages and disadvantages. And this is what this slide here is outlining. So going a little bit deeper into this, visible cameras are great for forensic. It's great to see who is there. Is it male, female, red shirt, blue shirt? Obviously, that's going to be the best advantage with a visible camera than using your VMS or some sort of third-party software to do analysis to be able to really see and pinpoint who did something. But for perimeter, especially at those outer areas, visible cameras may not always be our best bet because often we need to look at farther distances, we need to see wider spaces, and we're fighting challenges like lighting and drastic weather changes. Invisible doesn't always perform best in those types of environments. So for there, we often look at thermal cameras. Thermal cameras are always going to perform better in those types of weather situations. They're going to perform better in low and no light situations. But thermal's never going to be able to tell you who is there. But they do a phenomenal job of being with the analytics on board, especially our analytics at Flir, about telling you what is there. So is it a person? Is it a vehicle? If it's not either of those, then it's just a other object. Usually it won't alarm because it's not classifying in the algorithm as a person or vehicle. Those are the two types of analytics that we're often looking for the most when we're dealing with perimeter systems. And so knowing that there's advantages and disadvantages of both of those technologies has led us into creating a slew of different products in the multispectral range. We got a little picture there of our fixed mount solution, which is the FH, but we have a handful of different varieties of pan tilts as well to have thermal and visible, which the pan tilts were often used for the tracking side of when we talk about the radars. But on the fixed mount or the pan tilts, having the option of both visible and thermal really kind of gives you the best of both worlds when you have the no and low light situations, the four seasons playing out, and all the different weather patterns. You get the best of both worlds. And then with our products on the fixed mount that are running the analytics, you can actually schedule which sensor you want to run which analytic on. And then finally, the radar is going to be your best technology to use when you're trying to detect presence of an object in a large open area. The radar that often paired with a pan tilt camera will do the detection and then hand off the communication to or hand off the tracking over to the pan tilt to follow the target as it's moving through the scene. So it's really setting up all of these different products in your perimeter that gives you the best advantage of being able to detect accurately, track the target, and get those farther distances in an early warning detection. So at Flir, we have all the products that do this, but we also have a special proprietary protocol called Nexus that allows all this to come together in a cohesive solution. And so what is Nexus? Nexus is a proprietary communication protocol that facilitates edge-to-edge communication, sharing geodata and tracking data, which eliminates the need for software to control tracking functions. It's a mouthful, but basically what this proprietary protocol that we have is, it lives on the cameras, and it allows our devices to communicate to each other directly. So we don't need to do all of the configuration at the server level because we're actually doing it at the edge. So what does this look like, and why does this matter? So in a traditional architecture, you have your devices at the edge, and all of them are connected to your VMS, and you're setting up all the logic in the VMS. So in this situation, it's going to be critical that each device has some level of integration with the VMS, because at the VMS level, then you're going to need to associate classify and set your alarm zones, associate those alarm zones when they alarm to certain other devices, such as a radar to a pan tilt. And then oftentimes in those scenarios, when the alarm happens, the radar is telling the pan tilt to go to a general area. So with a little bit of drift, or if the car is moving fast, every now and then you could miss something, or it could be a little off center. But it requires a lot of configuration at the head end. It also means if you're an installer, need to be proficient with that VMS, and then you're relying on that VMS to maintain the integrations with the devices. With Nexus, we actually take all that and move it out to the edge. And then what's communicating back to the head end are just the video streams that are coming from each individual device through OnVIF. So more specifically, all the configuration, the zone setup, the alarming, all of that's set up through the Nexus UI, which is in the devices. So what's even more important, and after we set all that up, is when the devices are communicating to each other, they're not sharing relative location information. They're actually sharing the geodata information. So when the radar picks up a target, it's actually sharing that coordinate information with the pan tilt, so that the pan tilt's tracking the coordinate data and following along in real time. So it allows for more precision. More importantly, for the installation side of things, you don't have to know how to do this type of advanced configuration in multiple different VMSs, because your UI is going to be the same every time it's a Nexus device or a Nexus enabled device. So therefore, you set it all up in Nexus, and then through OnVIF, everything's recorded back in at the head end. So what does this look like when it's in action? So here you have a video example of a multi-layered perimeter. What you're seeing here are actually two radars stitched together to create one giant zone, which is another benefit of Nexus. It's not multiple zones that you then have to configure zone 1, 2, 3. If they're overlapping, we can blend them all together, so it's one giant detection zone. That's picking up the target. What you're seeing is one of our multispectral pan tilts that's then following the target as the person is crawling through the grass right now. Again, another highlighting of the multi-layered approach. The radar's picking up the movement. We can't really see because there's not great lighting in this at night with the visible portion of this pan tilt, but we can see the person clear as day in the thermal side of things. So there's really no chance that that person is going to get through that detection zone without us being able to watch him or her run through. So finally, the benefits of Nexus. I mentioned this on a couple of different occasions so far in my presentation, but the ease of installation. If you just if you're doing more and more perimeter work, everyone has a different preference on VMS. But to be able to streamline your perimeter approach with just a uniform interface, that really saves a lot of time in the long run. The moving the intelligence out to the edge just allows for better response, faster response too. When we're sharing the geo information from device to device, it really streamlines the ability to do faster tracking. Multi-platform, having different form factors of the Flir products that have Nexus in there means you can do this type of functionality in a lot of different configurations. And finally, with the distributed architecture, you always run the risk when everything's being configured at the server that if it's a single site with no failover, if that server fails, then you're out everything. I mean, in this distributed architecture, if the server went down, but you had like redundant recording and things like that, all the configuration for the edge and the tracking and the perimeter is living in the edge, so you don't have to worry about single point of failure. So with that, I'm going to hand it over to Sean to talk a little bit deeper about leveraging the full benefits of Nexus and how this really helps with the installation and being able to set up or the tracking side of things. Sean?
Thank you, Matt. So Nexus is a very powerful protocol with a lot of functionality that Matt has been talking about. But how do you bring that functionality to the user? Well, you could use the VMS that Matt was just showing that you can get from Flir. There are some VMSs that have plugins. We'll talk about that in a minute. But there's a lot of VMSs out there. And so how do you utilize Nexus doing that configuration on the edge with whatever VMS it is that the customer has? Well, it's pretty simple. There's only 3 steps, and we'll go through each one of these steps individually. But the first one is use Raven. What is Raven? Raven is an online tool that we have to map out a system, plan where you will place the cameras, where they will be looking, the radars. You can use Raven to do that, and very shortly, Raven will be upgraded to allow you to download the georeference map files for each of those sensors that you've placed in Raven. So we'll talk about that in just a minute. Step 2, through Nexus, you put those map files you got from Raven into the different devices, create the zones, link them together. And then step 3 is each one of these devices, including the radar, has an ONVIF video stream that will go into any VMS that will accept ONVIF video streams, which is most of them. So the cameras will all stream their video and the radar will stream a map. So here we have our Raven system. Oh, go ahead. Here we have our Raven system. This is just a quick example. You can get to this on the web. You put in your address, and then on the left, you have the devices. You click on security. You click on the map. You can select which camera model that it is that you want to place on the map there. You can select, the range, the direction it'll be pointed. Here's a radar. You can just drop a radar on the map the same way. You select the radar model, and then you can select what you want to look for, the direction it's pointed, a walker, a vehicle, a crawler. It gives you the range indicator there. You put another camera on here. If you put it in the wrong spot, you can just drag it where it needs to go. And then again, you just select from the list of cameras what type of camera that will be. Then we know the field of view. We'll know the direction that it's pointed, what that camera's purpose is. And then once you have all of these devices laid out for your system, then it's as simple as clicking on, or it will be very shortly, as simple as clicking on the download map button. And then for each of those devices, you'll get the map file and all the georeference coordinates that you can upload to the camera. Now, you may need to adjust slightly when you're in the field if the camera isn't exactly placed on the map correctly, but you'll have all of it ready to go for when these systems or these devices are installed. Go ahead, go to the next slide. So once you have those georeference map files, you can add the zones, you can link the cameras together. And you can fuse radars together. We'll talk about that in just a minute. And do all of that within Nexus. So the cameras know which radars tracks they're tracking, where the handoffs happen. And then step 3, if you go to the next slide, is simply just link those video streams into your VMS. The top one there that you see, that's the web interface, the Nexus interface for the radar. So it actually has the map, and it will stream that map out as a RTSP on VIF stream to your VMS with live updating tracks on it. So even if your VMS has no mapping capabilities, in your video wall, you can have an aerial view of your location, the map with live updating tracks on it. And then below is the on-VIF setup for the stream for the camera. So you can have a run-of-the-mill VMS without any of this advanced tracking functionality, but yet you can still have a powerful perimeter security system utilizing Nexus along the edge. And if we go to the next slide, here's a video of what we were just talking about. So in this particular video, we have multiple cameras and radars, and you can fuse the radars together. So as you have these radars and you're doing a perimeter system, they can all overlap each other, but you won't get 2 tracks. When this person is running and going where there's 2 radars in an overlap view, you're not going to get 2 tracks. It'll fuse them together. All of this happens on the edge. Nexus does that itself. And then this map that you see on the left, this is the map that is streaming from the R290 radar into the VMS. So this map updating can be in any VMS that you have. On the right is the on-VIF video from that. This VMS happens to be our VMS, but if you go to the next slide, Matt, we'll have the Milestone VMS. Milestone has a plugin, a Nexus plugin, and that's what you see here. So they have a map, and this map is in Milestone. This is not streaming from the radar. So here you have a person, they're walking down an alley, and the Nexus plugin within Milestone is utilizing those Nexus sensors, and it's tracking this person here. He's going to go out of the field of view, so we lost him. But then if you wait just a minute, he'll show up on the other field of view, show up on the map. The camera will continue tracking. There he is, right there. And this is analytics. So we caught him through going through the alley on a radar, tracked him using the radar. Now we're tracking him via analytics, all within Nexus on the edge, and Milestone is displaying all of that. Genetec also has their RSA plugin that has a Nexus plugin. So all of that can be utilized in pretty much any VMS. When you have these Nexus devices along your perimeter, you can leave the VMS, whatever VMS you have, you can leave it in place, and you can utilize Nexus to level up for perimeter intrusion detection. And in any VMS, you can have a live updating map and the videos, radar tracks, all right there.
So Sean, before we go to the next slide, you had mentioned something. I'm going to go back to the other video on this one about fusing these zones together to create a single tracks ID. For those people on the call that maybe aren't as familiar or that are just getting into perimeter and radars and things like that, can you explain the benefit of having a single track ID to pair to the alternate, which would be multiple zones and multiple track IDs, and how that impacts an installation, and kind of elaborate on some of that?
Sure. So I think probably everybody's familiar with putting cameras along a long corridor or along a fence line, and you always want to overlap the cameras, right? So there's no dead spots, and that's with the cameras. That's pretty simple, especially in the old days where you didn't have analytics, you didn't have tracking, you weren't looking, you just wanted unbroken video. But with radars, Radar's whole point is to generate a track that then you're going to look at. But with radars also, you want to overlap because you don't want dead zones in between your radars. You don't want people to be able to walk right in and the radars not see them. So these radars need to overlap. There's a couple of things you have to consider when you're doing that. Our radars allow for multiple, we'll call them frequencies, to simplify it a little bit, so that the radars aren't conflicting with each other. And they're smart enough, you can have a master radar and then link other radars to it. They all have the mapping in them. And then what that master radar will do is fuse those tracks together. So when it sees a track and another radar is reporting a track and it's in that same location, instead of sending data out that there's two tracks there because both radars see a track. Instead of sending that out, it sends out just one track ID. So a person, they can go through multiple zones or they can go through multiple radars. Walk down a fence line where you have multiple radars and they'll have the same track ID through the whole thing. So you don't get, one track ID and it's an alert and maybe it's no big deal and you acknowledge that alert. But then as soon as they go into another radar, you get another track ID and another radar, you get another track ID. We'll hold that same track ID through all of the radars, through all of the zones, because all of those radars are fused together. And Nexus makes it as if it's one radar that sees the entire area instead of multiple ones generating multiple tracks.
Awesome. Thank you. And then,
And finally, so Matt started out with this slide talking about all of these concerns, these challenges that people have especially as the area grows larger. A facility like this, an airport, anything that has large areas. So how does Flir resolve all of these challenges? Well, let's take them one by one. So poor lighting. Thermal cameras eliminate this challenge. You don't have to go through and put a bunch of lights up everywhere. Thermal cameras can see in the dark, no problem. Large open areas. Radars provide a wide area of coverage. You can put multiple radars, fuse them together, go around corners, around obstacles, and you can cover all of those large open areas. Inclement weather. Both radars and thermal cameras are less impacted by weather than visible cameras are, so they're a good augmentation to that. Limited connectivity. Seamless handoffs with Nexus increase your coverage, and Nexus FLIR thermal cameras have a wide array of lenses. We have multiple radars that can go different distances. So if you have limited connectivity, if power, if connection is an issue, we probably have products and ways that we can solve for that. Physical obstructions, I kind of touched on this already. A multi-layered approach will allow you to detect on all sides, and by fusing those radars together, it makes it very simple and seamless to the operator. Tracking targets. Nexus devices allow for continuous handoff, just like we just talked about. And finally, false alarms. By having radars and cameras and all these multiple layers, we can do further validation to lower false alarms. If one device sees it, but another one doesn't, or we can do that type of logic to make sure that we minimize false alarms as much as possible.
awesome. Thanks, Sean. Thank you, everyone, for attending. We're going to now open it up for questions. So please write in the chat, or if we can't remember if we can take people off mute or not, but we'll stay on as long as questions keep coming in. Thank you.